Hello, hello. Am I audible and is my screen visible? Can anyone please let me know? Is it audible?
Yes, it is audible.
Okay, thank you. Good evening everyone, welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Awan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. This is my 12th live session. So in this live session I will discuss some questions on week 12 topics, and if you have any questions or queries regarding these topics, you can ask me during this session. Okay, we will start solving the practice problems first. So this is question 1. Generalization error is given by this expression epsilon h equals probability of hx not equal to y, where x comma y is derived from capital D. So what is this capital D in this definition of generalization error?
The underlying distribution we are trying to estimate.
Yeah, you can write your answers in the chat. So the four options are: the underlying distribution we are trying to estimate, a sample of the underlying distribution, a different distribution that we are using to estimate the true underlying distribution, and the last option is the universe of distributions. You can write your answers in the chat. NS says B, Saishab Shah says A. Okay. Any other answers?
So here h of x is the predicted output and y is the actual output.
Yes, yes. Ritika Kesri says B. Okay. Harapriya Kaur says A, Ajay Chauhan says C. The correct answer is option A, the underlying distribution that we are trying to estimate. So generalization error is like a test error. The data set that the data points that the hypothesis or the trained model has not seen. So it is the underlying distribution of x comma y values that it is trying to estimate, and that probability value is the generalization error. So in generalization error, the distribution is the whole distribution, not just the set of data points that are given in the training data set. That there will be a training error, but generalization error, in case of generalization error, it is the error on the whole distribution of the data points x comma y. So option A is the correct answer. Now question 2. The hypothesis function obtained by empirical risk minimization is denoted as this. So h hat equals arg min epsilon h. Epsilon h is the error. H belongs to capital H. So the capital H is a class of neural networks which aspect constitutes its space. So this h hat or this small h is one classifier, and this capital H is a class of classifiers. In this case we are considering neural networks, so capital H is the class of neural networks, is a class of neural networks. So what aspect constitute its space? So what is the capital H in case of class of neural networks? Option A is different number of layers. Option B is different number of neurons per layer. Option C is different values for weights. Option D is different inputs. Ritika case says B, Harapra Kaur says B. Okay.
Are multiple options correct for this question, or is it only one option correct?
No, only one option is correct in this question.
There's a lot of audio disturbance. I would request somebody to mute their mic.
I think everyone is muted. NS says A, B, C. Okay. The correct answer is option C, different values for weights. So in neural networks we set the number of hidden layers or hidden neurons or hidden units, and then we train the neural network. So the space becomes the values for the weights. So values of the weights can be anything starting from minus infinity to infinity for each of the weight parameters. So different values of weights constitute the space of the class of neural networks. We don't change the number of hidden units or number of hidden layers while training the neural network. We update or change the values of the weights during training process. So different values of the weights constitute the space of the of a class of neural networks. Option C is the correct answer. Is there any doubt in this question? Question 3. as discussed in the lecture, most of the classifiers minimize the empirical risk. Which among the following is an exceptional case? Option A is perceptron learning algorithm. Option B is artificial neural network. Option C is support vector machines. Option D is A and B. Option E is none of the above. Ritika Kesri says C, NS says C, Sashab Shah says C, VG Satish says C, Harapriya Kaur says C, Meenakshi Atalkar says C. Okay, so far all the answers are C for this question. The correct answer is option C, support vector machines. So in support vector machine, we try to maximize the margin, but in case of other machine learning algorithms like neural networks and perceptron learning, logistic regression, all other machine learning algorithms, we try to minimize the empirical risk, which is basically the error. We try to minimize the training error. But in case of support vector machines, we try to maximize the margin. So margin is the shortest distance between the distance between the closest point and the straight line. So we try to maximize that margin in case of SVM. But in other cases, we try to minimize the empirical risk. So option C is the correct answer. Question 4. What happens when your model complexity increases? So option A is model bias increases, option B is model bias decreases, option C is variance of the model increases, option D is variance of the model decreases. So what happens when your model complexity increases?
I think model bias decreases and model variance increases. B and
Okay. So multiple options may be correct in this question. NS says B, C, Dakshana Murthy says C, Harapriya Kaur says D, VG Satish says B, C, Sashab Shah says A, D, Ajay Chauhan says B, C, Meenakshi Atalkar says A, C. Okay. Harapriya Kaur says B, C. The correct answers are B and C. So model complexity increases, that means it is overfitting, and in overfitting model bias will decrease but the variance will increase. So B and C are the two correct options here. Question 5. Aliens challenge you to a complex game that no human has seen before. They give you time to learn the game and develop strategies before the final showdown. You choose to use machine learning because an intelligent machine is your only hope. Which machine learning paradigm should you choose for this? Option A is supervised learning, option B is unsupervised learning, option C is reinforcement learning, option D is user random number generator, and hope for the best. C. Okay. Ritika Kesri, Vijay Satish, Aditya Siraj, Sai Sabza, Ajay Chauhan, Prashant Thope, Dakshana Murthy, Purabi Chaudhary, Meenakshi Atalkar, all are saying option C. The correct answer is option C. So all of you have written the correct answer in the chat. So whenever the task is sequential in nature, that you take actions one after the other, so a sequence of actions you have to take to reach the final goal or reach the termination state. In those cases, reinforcement learning is a much better choice than supervised or unsupervised learning. So in this case, you have to play a game. So game is a sequential process, and reinforcement learning works on that sequential process paradigm. Like it creates Markov decision process. So you are at a state and you take an action, you go to a next state, and you get some reward from the environment as feedback. So that's why reinforcement learning is the best choice of machine learning paradigm for this task. Option C is the correct answer. Now question 6. In the Pavlov's dog experiment, what is the input signal to the dog and what is the reward? Option A is bell and digestion, option B is food and praise, option C is food and digestion, option D is bell and food.
Option D.
Okay. Aditya Siraj says D, Dakshana Murthy says B, Harapriya Kaur says D, Saisabza says D, Ritika Kesri says D, Vijay Satish says D, Ajay Chauhan says D. Dakshana Murthy says D. Correct answer is option D, bell and food. So bell is the input signal and food is the reward. So it is very much similar to reinforcement learning and that you give a signal, so signal is the action here, and what is the reward that you get for that. So whenever the bell rings, food comes. So bell is the input signal to the dog and the reward is the food. So this Pavlov dog experiment is similar to reinforcement learning from that point of view. Question 7. Which of the following measure best analyze the performance of a classifier? So precision, recall, accuracy, time complexity depends on the application. Aditya Sirha says A. Ritika Kesri says E. Saishab Shah says E. Harapya Kaur says E. NS says E. Prashant Dhope says E. Dakshinamurthy says E. Puravi Chaudhary says E. The correct answer is option E. Depends on the application. So there is no single accuracy measure that is best for every application. So for example, accuracy might be a very good measure for non-critical tasks like playing games or classifying dogs or cats, like that. But precision recall, these measures are much more suited for critical tasks like health and security. In those domains, not just accuracy is important, but precision and recall values are also very much important. And so it depends on which application you are trying to measure, and also what is the class imbalance. On that thing also it depends. If the class imbalance is very high, that positive class is the negative class is much more in number than the positive class, then accuracy would be tilted towards 100%, which is not good. So in that case, precision or recall might be better depending on the application. So option E is the correct answer. Question 8. Which type of feedback does an agent in reinforcement learning receive? A. Predictions. B. Labels. C. Clusters. D. Rewards or penalties.
D. Reward.
Okay. Ritika says D. Aditya says D. Prashant says D. Vijay says D. Sai Sab says D. Dakshinamurthy says D. Harapya Kaur says D. Ajay Chauhan is D. Puravi Chaudhary D. Tanuj Rahul Reddy says D. So the correct answer is option D, rewards or penalties. So based on the action that the agent takes at a given state, it gets a reward or a penalty from the environment. Question 9. You are designing a reinforcement learning agent for a racing game. Among the following reward scheme, which one leads to the best performance of the agent for a racing game? So option A is +5 for reaching the finish line and -1 for going off the road. +5 for reaching the finish line, -0.1 for every second that passes before the agent reaches the finish line. +5 for reaching the finish line, -0.1 for every second that passes before the agent reaches the finish line. +1 for the agent going off the road. And option D is -5 for reaching the finish line, +0.1 for every second that passes before the agent reaches the finish line. Ajay Chauhan says B. Vijay Satish says B. Ritika Kesri says B. Vaibhav Shah says B. Harapriya Kaur says B. Prashant Tope says B. Manisha Devi says B. Dakshinamurti says D. Aditya Siraj says B.
B for Bombay.
Okay. So the correct answer is option B. So in a racing game, it's important to finish the race. So for that, we need to give a high reward. For example, +5 to for reaching the finish line, and not just reaching the finish line. In a racing game, we want to finish the race as fast as possible. So for that, for every second, it will give a penalty to the agents, so in form of negative reward, -0.1 penalty, reward is given to the agent for every second that passes, so that it learns that reaching the finish line faster would give a higher reward to it. So that's why option B is the correct answer. Question 10. You want to create a self-driving car software. In the context of the standard reinforcement learning framework, what would you classify as the state and actions? And note that your system does not have access to the previous states. So option A is state will contain current steering wheel position, current pedal position, current speed. Actions will contain turn the steering wheel, press the pedals. Option B is state contains current steering wheel position, current pedal positions, current acceleration, and action will contain turn the steering wheel, press pedals. Option C is state will contain steering wheel position, pedal position, and current speed, and action will contain change direction and change speed. And option D is state will contain steering wheel position, pedal position, and acceleration, and actions will contain change direction and change speed.
So it's A, option A, because it doesn't have access to the previous state, so it can't be change direction, change speed, because it doesn't know what is the previous direction of speed. So the actions have to be turn the steering wheel and press the pedals, and state has to be current position, current pedal, and current speed.
Okay.
So option A.
Yeah. Harapriya Kaur says A, Ritika Kejri says A, Shaisab Shah says A, Vijay Satish says A, Aditya Siraj says A, Dakshinamurti says C. Ajay Chauhan says A. Any other answers? The correct answer is option A. So the state should contain all the features to represent what is the current state of the agent. Here agent is the car, so it should contain all the features to represent the current status of the system. So to represent that, steering wheel position, pedal position and speed, these three values are required, these three features are required, but acceleration is not required. Acceleration does not represent the state of the car at a given point of time. Speed is a much better measure to represent the state of the car. So steering wheel position, pedal position and current speed, these are the three features that should be there in the state space. And actions, so actions should be turning the steering wheel and pedal position. So actions should contain all the things which can make state transitions, or which can change the state of the system. So in case of a safe driving car, if you turn the wheel, it changes the state to a different state, and if you press the pedals, it will change the state of the system, because state contains current, speed and also pedal position. So if you press the pedal position changes, speed also changes. So pressing the pedal also changes the state of the system. So action should contain turning the steering wheel and pressing the pedals. So option A is the correct answer. So option C also contains change direction and change speed as the actions, but those are not specific actions. So because in case of a car, changing direction, changing speed does not represent specific actions. It should be turning the steering wheel to change the direction and pressing the pedal to change the speed. So that's why those actions in option C are not specific. So option A is the correct answer. Question 11. Which of these classifiers do not require any additional modifications to use them when we have more than two classes? So multiple options may be correct in this case. Option A is decision trees, option B linear classifiers, option C is SVMs, option D is k nearest neighbors.
A and D. Decision trees and K and N.
Okay. Ritika Kesri says B and C. Saraswat Shah says A and D. Aditya Siraj says A and D. Ritika Kesri says A and D. Ajay Chauhan says A and D. Anyone else? Prashant Dubey says A and D. Harapriya Kaur says A and D. Gagandeep Bhatia says A and D. Okay. The correct answers are A and D. So decision trees and k nearest neighbor. So for these two algorithms, we don't need any modifications. They are already suitable for multi-class classification tasks. But in case of other algorithms like linear classifier, we need to modify the algorithm because number of units in the output layer will change, and we also might need to change the activation function. Same is the case of neural networks. We might need to change the number of hidden number of units in the output layer and also the activation function. And for support vector machines, it is suitable for two classes, but if we want to do it for multiple classes, then we need to modify the algorithm based on how many classes we are using. And but for decision trees and k nearest neighbor, we don't need to modify the algorithm. They are already suitable for classifications with more than two classes. So A and D are the correct answers. So these were the practice problems that I wanted to discuss in this live session. And now if you have any other questions or queries, you can ask me now.
Sir, my question from the Gaussian mixture model, sir.
Yes.
You can please explain the working of Gaussian mixture model.
To explain the Gaussian mixture model, that would take much longer time, and it will also contain a lot of mathematics and calculations. So the basic concept in Gaussian mixture model is that so you try to model the complete dataset or the distribution of the dataset as mixture of multiple Gaussian distributions. So 2, 3, 4 Gaussian distributions, and you try to estimate the parameters of those Gaussian distributions like mu, sigma and pi, mixing coefficient. These are the parameters in that Gaussian mixture model. So you try to estimate those using the EM algorithm or expectation maximization algorithm. So multiple Gaussians would be there, and the mean, so this is like mean mu1, mu2, mu3, and the standard covariance matrix should also be there for every Gaussian, and mixing coefficient is basically how many elements are there in each of the clusters. So these are all different Gaussians or clusters, 3 clusters, so mixing coefficient is for that, and the main goal is to find out these 3 parameters, mu, sigma, pi, using the expectation maximization algorithm. So this has been taught in the class, so if you go through the video lectures once again, you will be able to understand it properly.
Sir, I have already gone through the video lectures but could not able to understand.
If you can't understand from the video lectures, then you can go in the internet and find out other material there. I mean, on YouTube there are multiple videos are there which explains it in a simpler way, and also in the reference book it is also there, it is explained there properly with those mathematics and the whole EM algorithm. Is there any other questions?
Sir, in assignment 12, question number 8,
Yes.
in the current assignment 12.
Yes. What is that question?
So how to what is the Vx1 after V convert? So I didn't understand what is the V conversion.
So V is the value function. So value function is V of S is the value function for a given state, and using the RL algorithms, like different algorithms, dynamic programming, whether it's Monte Carlo, Q-learning, TD algorithm, the main objective is to estimate this value function for every state. So after training for several thousands or millions of episodes for any task, this value function for every state should converge to a certain value. Then only you know that it is completely trained. So that is the convergence, that it for every state V of S should converge to a certain value, otherwise you need to train it further.
Can you show the question?
Question I cannot open from here because I am presenting it from my tab. So question I don't exactly remember the question, but it is based on a numerical question based on the value function. I have seen that. So the value function is simply the expected cumulative reward from this state is, and you have to use those Bellman equations to estimate the value function iteratively, and after training it for several episodes it will converge to a certain value, otherwise the calculations might be wrong.
So conversion is when for any other data, the any other iteration, the value will not change.
Yeah, the v of s will not change for every state s, so it will not change in subsequent episodes or iterations. Then you can say that it is converged.
Okay.
What is the difference between TD learning and Q learning?
I mean, that question is given in that assignment I have seen, so I cannot answer that.
But actually, no. But in the video lectures, he has not mentioned anything about Q learning.
Yeah, try to understand the TD learning, what it does, and Q learning, what it does differently, and then you'll be able to find the difference between these two.
Yeah, that's what I asked you. Can you just say what is TD learning, what is Q learning? I'm not asking you to tell me the answer to the assignment.
Because in TD learning is temporal difference learning. So for every state that you visit in an episode, you update the value function based on the temporal difference value that you compute. And in case of
temporary difference between what and what? Temporary difference between
what you observe in that episode and what was the previous value for that state.
Okay.
And in Q learning, you try to estimate the Q function or the state action value function, computing and also for that Q learning you have to compute the temporal difference, but you are estimating the Q function there.
Okay.
Now that is these are the two different algorithms. So in TD learning, you try to estimate based on the temporal difference for every state. You estimate the value based on the temporal difference, and in Q learning you estimate the Q function or the state action value function Qs comma a, that you try to estimate. There also you use the temporal difference value to estimate that.
But I think in Q function you calculate ahead, isn't it? Like what will happen in the next 2 to 3 states? Is it something like that?
No, there is one step you can do case step. So you can also do that in TD. That one step case step, that is not a major difference. You can incorporate that in any of these two algorithms, that you can look ahead and do it. But that I don't think that is the difference between these two.
Sir, is there negative marking in the exam?
That I don't know. You have to ask in the discussion forum for that.
Sir, please explain the concept of exploitation and exploration in brief.
Exploration. So in reinforcement learning, for every state you need to explore different actions, otherwise you will not know which action is better than the other actions. So that is exploration. You should explore more, but you shouldn't explore always. You should also exploit what you have already seen. So that is exploitation, exploiting what you have already observed in previous episodes. You should exploit that so that you estimate and converge the value function for that state action pair. And exploration is trying out different actions at different state, exploring different actions for the given state. So there should be a trade-off between the exploration and exploitation, and for that you have this exploration rate for every algorithm that you set it to, for example, 0.1. so with probability 0.1 you will explore, otherwise you will exploit whatever you have already seen. So if there are no other questions, we can end this live session now.
Will there be any other sessions like a recap of the whole thing? Or this is the last?
There will be one extra session from my side on Thursday, I think Thursday 18th April from 6 p.m. to 7 p.m. I think all of you will get an announcement mail similar to what you get for every live session. So I will conduct one extra session on 1 hour session on 18th April, Thursday. Okay, thank you everyone for joining.
Sir,
Yes,
wait a
yes.
Sir, the complete link clustering the question given in the assignment 10.
Yes.
I am just sharing the solution.
So complete link was the correct answer changed later on, or
No change.
then I don't know. I mean, many of the students have written in the discussion forum that the two closest clusters should be merged. So, but I don't know whether they have re-evaluated it or not. So it would be better if you write it in the discussion forum once again for that. If they find it wrong, then they will change, or if they find it right, then they might not change. So I am not sure about that.
It means our solution is wrong.
If it has not yet been changed in the solution, then that might be the case, and if it is changed at some point of time, then your solution might be right in that case. But have they explained it again, why they are using their method, that they
I
are
am just showing. Wait.
Yeah, it would be better if you write in the discussion forum again and ask them to explain their solution, and if they find it wrong, then they will certainly reevaluate it for everyone, but if they find it right, then they would not change it. So it would be better if you write in the discussion forum once again to let them know.
Okay.
Sir, there is one question from my side.
Yes.
In assignment 11, question number 2, the fifth option was deemed to be wrong. I have written that equation in the chat. Can you please explain why that option is not correct?
In assignment 11,
Right.
pi j greater than pi k implies gamma z n j greater than gamma z n k. Let me open it once. In which question? Assignment 11?
Question number 2.
Question 2. Following is true of the responsibility terms. No, definition of pi and j are completely different. Pi and gamma, responsibility, and pi is the mixing coefficient, are completely different. So it doesn't mean that if pi j is greater than pi k, gamma of z n j would be greater than gamma of z n k. So those are completely two different. Pi is mixing coefficient. It is simply what is the fraction of elements that are present in jth cluster, and znk is the responsibility term, that for a given data point j, what is the probability that it is or for a given data point k, what is the probability that it is produced by nth cluster. So the definitions are different. So you cannot state that if pi j is greater than pi k, then gamma of znk would be greater than gamma of znj would be greater than gamma of znk. So that is not the case. So if you
Okay.
look at the the definitions of these two, you will understand that those two are different.
Okay, sir.
Okay. Thank you everyone for joining.